Good afternoon, everybody. Warm welcome to the second session of third day, 1 week faculty development program on sustainable additive manufacturing in medical applications, UNSDG perspectives, organized by Lord's Institute of Engineering Technology, Hyderabad, and sponsored by AICTE ATAL from 15 June to 20 June 2025. Let's get started and make the most of this opportunity to learn and grow together. And I request all the participants to feel free to modify the messages to fit your specific needs and style for this session. To welcome our today's second session chief guest, Mr. Arif, who is a BTech graduate from Jawaharlal Nehru Technological University. He has an experience of 8 years. Right now, he is acting as a managing director and 3D Levin Engineering, Hyderabad. So, huge round of applause for our today's chief guest, Mr. Arif. Mr. Arif, sir, we welcome you. And the session is all yours, sir. Thank you.
Yeah. Hi everyone. Good afternoon, sir. Good afternoon. So this is Arif. As you know, I'm working with 3D Levin Engineering as a director. So I'm here to introduce about reverse engineering and 3D scanning. So I'll like to a small brief about the reverse engineering and 3D scanning. So then we'll go to this PPT show. So how many of you know reverse engineering? About reverse engineering, is there any idea about you? Yes, please. Yes. Yes. Somewhat like yes, half of this is correct, but it comes under this inspection process. Whatever you said, it will come under inspection process. So for engineering components, if we have to manufacture the engineering components, so initially we have diagrams, designs, and then raw material and production, and then finally we'll get output. In this reverse engineering, so initially we have the output, which is as a component, as a product, whatever it may be, and then and then we have to scan the component. Then we'll get some raw data, which is known as mesh files, and then we extract the dimensions from the data with the help of softwares like Geomagic, PointShape, NX, Creo kind of softwares, and then we'll go for production. So here we use scanners to scan the products, 3D scanners which are manufactured as laser scanners, white light scanners, and then structural light scanners. So we'll go for PPT. So today we are going to cover the topics: introduction to reverse engineering, how it works, reverse engineering methodologies, and 3D scanners, and the softwares which you use for reverse engineering, and the design workflow. So initially we have to find the component which we have to scan the component, and then its structure. If you have to scan a component, like if you want to measure a component, for example, if you want to measure this table, what kind of measurement device will you use? Sorry? Exactly, tape. And for some other components like this caps, 1 year. Sorry? Micrometers, 1 year. What if I ask for this mouse? Sorry. How can you measure this mouse? Can you get exact dimensions with the calipers? So when I get any complicated designs which are irregular shapes, then we go for 3D scanners. If you want to measure this regular shapes, geometrical shapes, then we go with measurement tapes, vernier calipers, depth gauges, kind of things. Then if we have any irregular shapes like this mouses and kind of car designs, bikes, everything, go with this 3D scanners. Yeah. So why our engineers use this reverse engineering process? Let's get it brief. Uh, if you have any, sorry, if you have any already a 3D model, and then you go with this production process, and you get the piece of production. So if you then you want to know how accurate the product is with this reference model, then we go with scanning options and scan the component and compare the whatever the scan data we get with this model which we already have. And then next, if you have any if you have any big mission and you lost the part in that mission, if you replace the part, then it will be then it will be a low price. If you are not able to replace the part, then the machine will replace the bearing cost will be high. The machine cost will be high. Then we use for replace the main component of the machine. We use reverse engineering. And then any the damage kind of parts in the machines or how much worn we have to know. Then we use this reverse engineering process. If you have some parts which are not available in we lost some parts in a machine or on a for any components, then we use this reverse engineering process and then reproduce this products. And then to analyze our competitive products, like if you are in competitive field which are providing same products by your competitors, then you have to make it better than your competitor product. Then you can bring the product and make it reverse engineer, and then you have to develop your product features better than your competitor product. Then we can sustain the market. And to improve performance and improvements of the product features, which are like ma'am said, to develop the existing model. So it works like after scanning, we will get a virtual model in in software, and then we compare with this physical model. It comes with scan mesh data, and then extract the information with the softwares like Geomagic with the mesh data and converts it into a 3D model. So these kind of scanners, like this is white light scanner. So these kind of scanner which do not contact the component and just this it doesn't contact the component and scan the component with a good accuracy like 40 microns, 20 microns. In some scanners we will get 5 microns accuracy also, and then we'll get a point cloud data and then convert into the mesh data. So these scanners will be worked with the laser triangulation method. The laser, it seems in this 3D scanners, laser we can call even white light also we can call as laser only. So this works on the principle of white laser triangulation method. So I'll show you one second. So it is white light scanner, where these LED lights are produce some lights. These LED lights produce some light like a kind of laser, but it's completely safe. And then it it uh, it shows on some like it depends upon this component. Then it will be captured by the camera. Like here, you can see it displays on this product. It captures the camera captures this deformation of the product in point cloud data. Sorry. It's kind of additive manufacturing. Like it comes with basic manufacturing. The any kind of manufacturing also you can do with this.
So you are saying that you are using different types of that sensor you are using. Can you measure the distance between one circle to another circle? One there is some
Yes.
deep hole is there and there is some extended part. Can you measure the distance between the 2 points and the diameter of those
Everything.
circle?
Everything.
So
Right,
how we
we
can
can-
save the data? In which format the data will be saved?
Like I said, mesh data.
Mesh data.
Mesh data will be saved.
Acha.
While capturing, we'll get point cloud data,
Yeah.
and then it will be converted to mesh data. So mesh data is it's in form of STL, a form of STL format. So the STL format will be we'll download this. We'll use Geomagic software. We'll bring this STL data in the Geomagic software, and then we reproduce the model, whatever it may be. What kind of model it may be, we'll reproduce. Did you get it or any doubt?
No.
So this is useful for R&D products also. Like if you want to do any R&D project, then if you go for example, this is the only product you have to manufacture. So if you want to know whether all the dimensions are correct or not, so we will scan the data and then produce a 3D model of it. With the help of that, you will produce the product. So if you want to know if you want to know this product dimensions are correct or not, whether it's fixing at correct place or not, then we don't go for die making or mold making, because it takes more cost effective. So that's why we go for 3D printing first, and then we'll print out this product, and then we check with existing products. If there is any modifications in there, then we'll again modify it, and then again we have to check it until we'll get the proper dimensions. So this is also used in CAD analysis and FEA finite element analysis also, for which provides the data, the distance and the circularity, parallelism, flatness, all those properties will have to can check in this STL data. So initially this STL data is in free form shape. You can cut it, you can like hole it, then it will be converted into dimensional shape with the using of Geomagic and point shape softwares. So these kind of irregular shape can create easily in this with this 3D scanners and reverse engineering process. If you want to measure these components, it is impossible to measure with scale or verniers. Then we go with 3D scanners. So when 3D scanners are various types of 3D scanners. For different measurements, we'll use different types of scanners. For example, these kind of components we'll use the tripod based scanners. Which one is this? Which is used for which uses the structural light and come with 5 to 10 microns accuracy in dimensions. And this kind of tripod scanners are used for big kind of components like ships, aeroplanes, helicopters. For those we can scan with this tripod based scanner, tracker based scanners. These are arm kind of scanners. Initially it has a bench kind of thing, and then it is placed on this bench with 00 mark 00 pointing, and then we have to move this arm for measure the total component. These are handheld scanners which can be used as like this also. In handheld there are two types, white light and blue laser. So white light scanners are used for normal human faces or any kind of structures which are statues. Kind of we can scan with the scanners. And if you go with blue laser scanner, then we go for like we can scan with mechanical components. So we can use it in concept designing, manufacturing, servicing. So clay modeling also we have done. Initially, while in R&D of a bike or car, initially they use the modification designs with clay only. While they are completed in clay, then we go with 3D scanning, and then we convert this physical model into digital model by with the use of these scanners. So whatever this blue color component shows is scan data, and then this gray color is the design data which is come from scan data. So mainly we use this reverse engineering for jigs and bores, dies, molds, and CAD file to reflect as built tooling measurements. So this is used for reverse engineering development of developing replacement or restoration of parts and planning to complex assemblies and assemblies. So if there is any big kind of machine, then there are some assembly kind of components. So to find out those components which we have to disassemble and can be regenerated, though we can find out with this scanning also. So application industries are oil and gas, healthcare, education and research, like computer graphics. You can use this scan data in graphics also, like for movie graphics.